Okay, now we're gonna move on to question 6. So question 6, they want us to find angle BED, which is the angle that I have indicated, and then they want us to give a reason. Okay, so the first thing that we can deduce, right, is that angle AED is equals to 90 degrees because this is angle in a semicircle. Okay, so we know that this entire thing here is 90 degrees. Okay, then now we can find angle ADE. So angle ADE is this angle here. So how do we find angle ADE? Sum of angles in a triangle. So angle ADE equals to 180 degrees minus 90 degrees minus 35 degrees. And this would give us 55 degrees. Angle sum in a triangle. Okay, and then now we can finally find angle BED, which is equals to 180 degrees minus 55 degrees minus 48 degrees. Okay, so this would give us 77 degrees. And how do we know this? Angle BED is over here because it is interior angles. How do we know? Because BE is parallel to CD. Okay, so these two, they are parallel, and hence we can 180 degrees minus the two known angles. Okay. Okay, let's move on to part B. So this is 77. So now we know BED is 77. BEG is over here. So it's over here 77 degrees. Okay, so ADE we found just now was 55 degrees. So this one over here is 13 degrees. Sorry, not, okay, yes, it's 13 is correct. Okay, fine, now they want us to find angle BCE. So angle BCE is over here. Okay, so how do we find angle BCE? So first we need to find angle BCD, which is this entire thing here. Okay, so how do we find angle BCD? Basically, we can just take 180 minus 77 because it's angles in opposite segments. Okay, angle BCD equals to 180 degrees minus 77 degrees equals 103 degrees. Angles in opposite segments. Okay, then we know that angle ECD equals to angle EAD equals to 35 degrees. Because why? These are angles in the same segment. Okay. Okay, then now we can find angle BCE. And this would just simply be 103 degrees minus 35 degrees to give us 68 degrees. Okay, so angle BCE here is 68 degrees. Okay, so now this is 68 degrees. Okay. All right, moving on to part C. They tell us that the radius of the circle is 5 cm and they want us to calculate the area of the major sector OAEDC. So OAEDC. Basically, they want us to calculate the area of this major sector here. Okay. So we know that the radius is 5 cm. So we know that this is an isosceles triangle here. Okay, so now we are going to find the angle over here. So that's angle DOC. Okay, let's find angle DOC first. So angle DOC is 180 degrees minus 48 degrees minus 48 degrees because it's an isosceles triangle. So that will give us 84 degrees. So this is isosceles triangle with OC equals to OD. Okay, so now we know this is 84 degrees and this is 48 degrees as well. Okay, yeah. And then now we can find the reflex of AOC. So the reflex of AOC is this entire angle here. Okay. So the reflex angle of angle AOC is 180 degrees plus 84 degrees to give us 264 degrees. And then now we can find the area of sector. Okay, this would be 264 degrees over 360 degrees times pi r, which is 5 squared. So this would give us 57.595. Round it off to 368. We will get 57.6 cm squared. Okay, so this is your answer, 57.6.